All right. Well, happy Friday and happy November. It's November 1. So just a few weeks left in the quarter and I guess the year. We're I don't know. Okay. Um, Here we are. November. All right, so today we'll look at Matplotlib because eventually I want to just show you some like how to do some exploratory data analysis in Python. And so we've covered pandas, at least like how to do some grouping and pivoting. And then another big part of exploratory data analysis is, being able to create some visualizations. And kind of the I don't know, the most commonly used data visualization tool we have in Python is Matplotlib. Now, I will be honest, I like ggplot more than I like Matplotlib, okay? So, that's fine. But, it gets the job done. It's okay. Now I sound made to sound bad. Okay, but it's not bad. You can do quite a bit with it. I just prefer ggplot at the end of the day. But here we'll cover a lot of kind of things you can do. Matplotlib integrates very well with data frames in pandas, and so a lot of pandas data frames you can just call plot directly on them, and you can produce plots, and that's kind of nice and handy. So anyway, let's just go ahead and take a look. We'll see how much we cover in this notebook today, and then you know what? Let's take a look, and we'll do more next week and whatnot. Okay, so if you don't have Matplotlib already installed, you will have to run pip install Matplotlib in your terminal. And then, of course, after any time you install a module, you'll want to restart your Python kernel in VS Code. Okay, and then and when you import Matplotlib into your Python script, the convention is matplotlib.pyplot as PLT. Okay, so NumPy comes in as NP, pandas as PD, and matplotlib pyplot as PLT. And so we'll go ahead and run that and get that loaded, and then we can create a very simple plot. So here, I'm going to just create a NumPy array. I'm going to have 500 values going from 0 to 2 pi. Okay, so we're just going to create, I don't know, a bunch of spots on a circle, and then we can do sine of x, NumPy sine of x. And so when you go from 0 to 2 pi, we'll create a plot here. Okay, so x is going to be 0 to 2 pi. Y will be when I plug in those 0 to 2 pi into the sine formula or sine function. And then let's create a plot. Okay, so when you create a plot, you call plt.plot. And then to have the plot appear, you call plt.show. Okay, so plt.show is a lot like calling print on to get a plot. If you're in Jupyter or in this kind of notebook, okay. So I know you're in VS Code, but the notebook is powered by Jupyter, okay. Even if you don't call plt.show, Jupyter tends to just kind of produce the plot anyway, but it's still good practice to call plt.show. You can also put in other arguments like changing the title, changing the x limits, things like that. These are optional things. But here I'm going to just go ahead and do plt.plot, X and Y, PLT title, we're gonna put in the title of that. We'll put our X limits and then we'll call PLT shell. And we get exactly what we expect because we're plotting X, which is just the values 0 to 2 pi, and Y, which is the sine of X. And so there you go, okay? So going around the unit circle, it goes from up to 1, down to -1, back to 0. Okay. The default behavior of plt.plot is to, if you have kind of pairs of points, X and Y, the default behavior is to connect them with lines, which may or may not be what you want, because maybe you want a scatter plot. So here I just created a vector X, 0, 1, 2, 3, 4, okay? Random values of Y, 9, 0, 1, 2, 2. If you run it, you might get different values of Y. And here it just connects them. So we have 0, 9 connected to 1, 0, and 2, 1, and 3, 2, and 4, 2. And so these are points, but then they just got connected together with a line. And so, you know, so this is technically 500 dots, but they're all connected with a line, so it looks like a smooth curve. But they're technically just 500 dots. And generally speaking, when you see something that looks like a smooth curve on your computer, it's not actually a smooth curve, right? Because everything down there is just a whole bunch of pixels, okay, which are discrete locations, but we just kind of color them in, and a whole bunch of them together. Our eyes think that they're smoothed out, but underlying generally, it's not. Okay, if you just want the individual dots not connected with a line, you can call plt.scatter. So I'm going to take the same values of X and Y here, and we're going to get a scatter plot. Okay, so these are these dots, 0, 9, 1, 0, 2, 2, 1, 3, 2, and so on and so forth. So you can see it's the same things, just dots there. Okay, and that's that. All right, you can put multiple things on the same graph. So here I'm going to have X go from 0 to 2 pi, and then I'm going to have Y, Z, and W. Y will be sine of X, Z is tangent of X, W is cosine of X. And you can call plot multiple times, and you can provide an argument for like what color you want. So I want to say, hey, plot X and Y in blue. So sine will be plotted in blue. And plot X and Z in red. So the tangent in red. And then I'm going to say, show this plot. And when we do this, it does it. And it looks like this. So tangent of X, you know, when it gets to, what, pi half and, I don't know, what is this, 1.5 pi? Okay. It goes off to what, positive and negative infinity. And you know, because the way I did it was, I don't know, it never actually hits pi halves exactly. It just gets really close, like 1/500th to the right and 1/500th to the left or whatever. So we get, you know, kind of these artifacts of this thing where it's not quite negative infinity, it's only negative 300 or whatever. But the scale of this thing basically smashes the scale of sine of X, because sine of X wiggles from -1 to +1, but, you know, on the scale of, you know, -300 to +300, you can't see it. So, you know, plotting tangent of X is not really the most interesting function, you know, if you try to fit the whole thing, okay? So, but perhaps better, we'll do sine of X and cosine of X. All right, so we'll do X and W in blue. I mean, X and Y in blue, so sine of X in blue, X and W in orange. So cosine of X in orange, and then there you go. Sine of X starts off at 0 and goes like that. Cosine of X starts off at 1, goes down, right? So we have that. Okay. You can add additional things, changing your labels and axis limits. So plt.plot, and then we'll change the titles and the X label and the Y label. So by default, this is kind of what it looks like. So we don't have, normally, the default is you don't get any title. You don't get any label on the X other than just the values, and labels on the Y, nothing. Just plots out the numbers, and then it pads a little bit of space on the top and bottom, left and right. Okay, so here I'm going to just go ahead and put in labels. So here's sign of X, the title. The X label is X, the Y label is F of X. Okay, we get a little bit of padding on the top and the bottom, and we can change that. So I can say X limits go from 0 to 2 pi. Okay, and then as far as the axis, okay, you can do axis equal, and that's going to put everything on. Is going to change the aspect ratio. So here, the top and the bottom range from -1 to +1, whereas X and Y, the X-axis goes from 0 to 6. Okay, and here we can say we want an aspect ratio of 1, so that this is what it looks like. And that'll be important if you try to plot something like a circle, a unit circle. If you don't have the same aspect ratio on the X and Y axis, then your unit circle will look like an oval or a flattened thing. So, so if you want circles to look like circles, you'd want to use axis equal or something like that. Okay. Oh, my X limit. Oh, okay. I think I have to put axis equal before I change the X limit for it to apply, because. Okay, so you'll have to fix this. But if you set the X limit first, and then you choose axis equal, then axis equal readjusts the X limits, and it throws that off. So we'll do axis equal first, and then X limit, and then it gets fixed. Okay. You have other options, okay? So here you can do, you can change, so if I just call scatter, PLT scatter on X and Y, okay? You can't really see, but these are like there's 500 dots, but there's so many of them that they all just kind of get joined up here, okay? So, if I just zoom in from, say, 0, say, 0.1, okay? Now we just get all of these dots kind of real close together, okay? You can also change, so the default are those circles, but you can change the shape that gets plotted to other things, okay? So some options, you can change the shape to a D. I think those are going to be diamonds. Shape to a star, and you're going to get little stars. You can change the size of the dots. So here I'm going to do size 30, size 80, and you can also change the colors of the things. So here are the stars, okay? Here are the diamonds. I can change some of these. If I change this to 300, I think these will get really big diamonds, okay? If I get rid of the size, I think, I don't know what the default size is. Little diamonds, medium-sized diamonds, okay. Changing the colors. And so you have different named colors, right? Maroon, dark slate gray. I don't know what these things are, okay? So let me just show you some of the colors. Basic colors, you can just type these things out by name: blue, green, red, cyan, magenta, yellow, black, white. You can also just use the one-letter shortcut. And so blue, green, and red is B, G, and R. And that's pretty simple. And then this is kind of the list of named colors. So here are the different colors by single letter. You can also type in, I don't know, I think these are like Tableau colors. So if you want Tableau blue, I think you can do tab:blue as the color. So let me just do regular blue and tab blue. So you have this blue versus regular blue. Can't really see the difference up there, but okay. And then you have Tableau cyan. I don't know if there's a difference between that and regular cyan. Yeah, there is a difference. Okay, so that's regular cyan, and this is Tableau cyan. It's a very subtle difference. It would be ill-advised to use these three colors on the same plot. Okay, you want to make it easy for your users, and especially if somebody has. That's not me, is it? Okay, I don't know what that is. All right. All right. Well, anyway, you have all of these named colors. So, ta-da! What do we have? We have. Oh, look at that. Dodger blue is an option there. Light slate gray. Light slate gray. What? Oh, this is gray with an AY and gray with an EY. Are they doing construction? Oh, but they're just doing it like right there? It sounds like it's coming from, I don't know where my, okay, well anyway. How do we spell gray? Is it spelled with an A or an E in America? I don't know. Okay, well anyway. Nobody knows. All right. So these are the named colors. It's a little distracting. Line type. Okay. Oh yeah. So this is in my opinion so dumb, but this is how you specify different line types. So if you want a solid line, well, you don't have to specify anything. That's the default. Okay. But the line style you can specify by putting dash here. You can by putting a hyphen in quotes. But then if you want a dashed line, you put in 2 dashes in quotes. And then if you want a dash dot line, you put a dash and a dot in quotes. And if you want a dotted line, you put in a colon. And I guess this is like a pictorial representation of how you want the thing. And I don't know. It's fine. I would have just rather have written solid dashed, dash dot, and dotted, but I'm not the one who designed the language or the package, and so this is what you get. And so, so this is that by default. It plots the things in different colors when you keep adding them. But you know, this is especially useful if you're going to say like print something in black and white. Okay, you can't print different colors. And so if you want to distinguish different lines, you can do that, and you have different line things, okay? And I think, are there more line styles? Oh, okay. No, you can actually, okay. You can write solid, dotted, dashed, and dash dot. Okay, I don't know what I'm talking about then. So I can write this, solid, dash, wait, dash dot and dotted. Oh, this is way better. Oh, okay. All right. Somebody must have taken my notes. All right, so you can put in the words instead of just. All right. Well, that's better. Okay, and then I guess if you really wanted to, you can parameterize the line style using some kind of tuple of things. But this seems painful to do. All right, four different named line styles. That's probably going to be your limit, because you don't want to give somebody a key that looks like this and say, oh, look at the dashed line, but the ones that have loosely dashed versus long dashes with offset. That's, again, the whole point of data visualization is so that the person viewing the graph prefers to look at the graph than look at the data directly, okay? And that it's easier to look at the graph and understand what's happening in the graph than it is to look at the data directly. And if you're not achieving that, then your data visualization has failed, okay? All right, other things. Okay, you can change the figure size. So if you're going to do this, first define the figure size first. Then you do all of these other things. So here I'm going to just do some random dots. Okay, so here it is, figure size 4:4. I don't quite know what these, how big is my screen? Okay, but here's a 7 by 7, and then here's a 10 by 7. Okay, here's 12 by 4. Okay, and here, because I said axis equal, it only fills in here. But if I comment this out, then it spreads it out accordingly. Okay, so play around a little bit. So I don't know how big. What is this 16? I don't know. How big is? No. See, I don't know. Once you go over a certain number, it doesn't get any bigger than the thing. What do you call it? VS Code has this thing where you hover over a plot and you can click the expand the image. But I don't know. Okay. Anyway, 4 by 4. This is what we get. Axis equal. That's what we get. More options right there. Okay, so here I'm going to change the, we've got these dots here, okay, and I want to change what it's going to look like. So you can provide a vector of sizes, you can provide a vector for the colors, and so on and so forth. Okay, so I'm going to have sizes anywhere from 100 to 1,000, and then I'm going to provide kind of an array of colors. All right, and so my colors, I'm going to have red, blue, green, magenta, yellow. And then you can kind of plot these things with different values here. So I'm going to create a scatter plot, x position, y position. Okay, S being the size is going to be given by this vector z. So if you provide a vector of sizes, we have this, and then C equals C is going to provide a vector of colors, right? And then so some of the dots will be a size 1000, color green, size 600, color red, so on and so forth. I'm going to set alpha equal to 4, and so we have this. And so this is the exact same data as this, even though it looks a little bit funny, but you can see here I got 3 dots in a row here, these 3 dots, and those 3 dots show up here. It's just this one was blue, that one's green, and that one's yellow, and they're different sizes. But if you look at that formation, here's a little triangle of dots down there, and that same triangle of dots shows up right here as well. So same dots there, okay? And then I showed you a couple examples of changing the shapes, okay? Here, instead of circles, I could have stars. All right, so here's the same kind of plot, but with stars instead of circles. And then these are the different shapes that you can have. So you can have points, pixels, circles, triangle down, triangle up, triangle left, triangle right, try down, try up, try left, I don't know, whatever. Okay. Let's just show you some of these things. Okay, so here's circles and here's stars, but here is the up triangle. There's the up triangle. Here's the down triangle. Okay. A little elevator up and elevator down. What do we have? Is one the same thing? Okay? So you have the try down, which is, I don't know. This is like some. This gets hard to read now. Okay. Different shapes, okay? You want pluses, you can have pluses, you can have X's, okay? I don't know. And then if you could put little labels on these things. So here I've got label group A and label group B. And then if you do plt.legend, it puts a little legend in the corner of your plot there, okay? Oh, all right, let me give you, your first view quiz answer is B. B as in, B as in bear. First answer, B. Okay, you can also create subplots. So if you want like a complicated plot, or you have like something in the left and the right, you can do this. And you call subplot, and it does this, okay? So, but this is the stupid thing. All right? Subplots are one indexed, and they go by rows. So here I do subplot 2, 3, okay? And so that's going to create 2 rows and 3 columns of plots. And this is subplot 1, subplot 2, subplot 3, subplot 4, subplot 5, subplot 6. Okay? It's fine. You want 6 different plots here, you can do that. You call subplot, and then within each subplot, you do the plot of what you want. So here, I'm just doing plt.text, and that just prints text on the plot. Okay? So here, let me just show you an example, okay? I'm going to plot sine, tangent, cosine, whatever, okay? And then, so I'm going to create a subplots, a 2 by 2. So I'm going to have 4 plots. The top left one is, I'm going to plot x and y, so sine, and then I'm going to give it the title sign of x. Subplot 2, upper right, x and w, so that will be a plot of x and cosine. And then subplot 3 will be the lower left, and that will be x and z, the tangent. And then subplot 4, the lower right, I'm going to plot 2 things there, okay? And so here we get them, and then, all of them just get their own adjusted axes. So sine of x, -1 to 1, and cosine of x, -1 to 1, but tangent of x, -300 to +300. Sine and cosine, they get plotted together. And so this is how it goes. So you just you basically specify which subplot you're working in, and then you do this, okay? Now, if you're going to do this, you can also, if you're going to do a plot, probably it makes sense to, if you're going to do subplots, it makes sense to do a bigger plot. So you'll set figure size. So this is figure size 9 or whatever, and you get a bigger thing, and you can expand the image. And oh, I don't know how this works. Okay, never mind. But that's what you have there. Okay, so you can do that. Now there's also something called grid spec, and with grid spec you can specify even more complicated things. So subplots, basically you'll get even same size plots like in a grid there. Okay, but with a grid spec you can do something like, So with a grid spec, I'm going to do 2 by 3. So normally with subplots, you would get 2 by 3, but with grid spec, you can do something like, I want this one to be one plot, and then I want to join these two plots together, or something like that, okay? And so that's what I have here. Now, this is the dumb thing, is that grid spec uses zero-based indexing, okay? So with grid spec, I said, hey, for subplot grid 0, 0, do this, okay? And then for grid spec 0 and then 1:3, okay? So again, you know, this is 0, 1, 2, 3, and 0, 1, 2 now. We're going to do for 1:3, which is going to be this upper right thing. We're going to get that plot. And then here I said 1:2, so then we're going to get this one down here. And then for the last one, 1:2, we got that. You know, you can plot these things like that. So you can do something like grid spec. I would say don't do it. Just make 4 different plots, okay? And if you need to do something complicated, probably use R and ggplot. But it is possible to do complicated stuff. It's a huge pain, though. It's a huge pain, okay? Save yourself some trouble, okay? All right. Other kind of common plots that we make, histograms, okay? plt.hist, easy, okay? So make some random noise or random data, normal generation, plt.hist, plt.show. You do that. You can give it some arguments. You can change the number of bins. Now I can never remember the arguments for this. So I always you know, I always have to go matplotlib histogram. Okay, and then you know, when you look for arguments or look for search results, always go to the matplotlib.org. This is going to be your documentation. All right, you'll find things from different sites. W3 Schools. What is this? Geeks.org. I don't know. How to matplotlib.com. I'm sure they're fine. Okay, but the official documentation will be generally your best resource, okay? Official documentation. And so you'll find the different arguments and the different things that you can do. So use that, okay? So bins, 25 alpha is transparency. Steel, color is going to be, you know, what color it fills in. Edge color, black, so you can do that. And now it looks like this, the same data, but now smaller bins, and it looks, I don't know if that's prettier, something like that. Another option is step filled, which gets rid of the lines in between the bars, but it puts a line on the outside, okay? So it looks like this. I don't, you know, whatever. Visual preferences, okay? This is where Python **corgs, the keyword unpacking is kind of cool, okay? So here I've got 3 normal distributions, okay? And I want to kind of create all plots together. And here, instead of having to specify all of these things, here I have histogram step filled, alpha 0.6, density equals true, bins equal 25, edge color black. Okay, and I want to use the same arguments for all of these things. I create a dictionary with all of those arguments, and then I say, hey, unpack all of these dictionary things. So it's basically the same as like copying and pasting all of these arguments into, you know, into the plot like this. Okay. So you know, if I wanted to, I could change all of them all at once. All right, and I could make edge color red. That is hard on the eyes, but you know, you could do that. Bins, you know, let's say we want 100 bins, okay? Then you can have this really jagged looking thing, stuff like that, okay? Change it, you know, get rid of histogram type from step filled into just the regular thing or whatever, okay? So you can specify however you want, and you can, rather than having to copy and paste all of the same arguments across the thing, you can kind of have this uniform looking thing. All right, we also have 2D histograms, which look like this, okay? So here I'm generating some random multivariate normal values, mean at the location 0, 0, and this covariance matrix 1, 1, 1, 2. So we've got covariance of 1 in the x direction and covariance of 2, or variance of 2 in the y direction, and then there's positive covariance between x and y, which is what we see here, okay? And this is plt.hist2d. We have that. I can do plt axis equal as well, and that will make the x and y axis equal in size. And I don't know. So that's what it looks like. Hexabin, same kind of thing if you prefer hexagons rather than squares. So, okay. There you go. All right. And then, you know, if you wanted to print two-dimensional things, you could create, here I'm creating in this mesh grid, and I'm going to create this plot here, and you can kind of create I'm going to create a plot of all of this stuff together. So I'm going to do mesh grid x and y, and this will give me basically a huge array, okay? This is 100 rows and 101 rows, 101 columns, and you can create a contour plot in this. So a contour plot is basically, so in this case, I'm plotting the product of two independent standard normal distributions. So, you know, graphically, basically we have this standard normal distribution, and then it's a product of two of them. So we're getting a plane here where in one direction we have that, and then in the y direction you also have this, okay? And so you have this kind of this hill-looking thing, and so this is your contour plot. And so when you look from top down, it's just a bunch of concentric circles. But this is kind of what your plot looks like, right? Two-dimensional standard normal thing, and that's what it looks like. You can create a kind of a heat map, and this is what it looks like. But this is, you know, your top-down contour map of this. So that's contour there. Okay. All right, we're going to run out of time, but let me give you your second view quiz answer. The letter E, E as in elephant, E as in elephant. So even though Matplotlib isn't my favorite visualization thing, it is kind of an essential thing to learn in Python because pandas and Matplotlib integrate very well together. So you can create series or data frames in pandas, and then these series and data frames have plot methods that use Matplotlib directly. So you can kind of take these objects and then just call plot as one of their methods directly from it, and it will produce plots. And that's it's important and it's handy to know. So here I'm going to just create a simple series here. Okay, and this is just, I don't know, I just picked 1,000 days starting January 1, 2000, and just arbitrary plus and minus numbers here, okay? So what did I do? Just a random normal value. So we're going to go up or down, positive or negative. and then we're going to just run a cumulative sum of all of these things, okay? And we're going to call this TS. So here, after 1,000 days of plus or minus, you know, it goes up or down. And so this is a series. Basically, I've got a column of values, and then on the left, the index is just a bunch of dates, okay? And so if you take a series like that and you just say plot, so here I'm not even calling, notice I'm not calling matplotlib directly. I'm just calling, this is just my pandas series that I've just created here. So I did ts is equal to pandas.series, but this is a method that exists directly within the pandas series, and in here I call plot, and it just plots it directly. Okay, so it started off at negative 0.47, goes up to 0.59, 1.58, 2.14, so on and so forth. It just kind of bounces around, and by 1,000 days later, which is I guess 2002 September 26, it is down to negative 34, okay? And so we have these up and down movements. And you'll notice the y-axis is labeled appropriately, and then the x-axis is also labeled appropriately. So January 2000 to, you know, 365 days later, something. This is 1,000 days later would be, I don't know, July, August, September 26th, okay? And so on and so forth. So that's kind of like a nice little feature of Pandas series, is you can just, if you've got just numeric values, it's just automatically going to kind of plot this thing, okay? We can expand this and work directly with, say, like a data frame, okay? And so here I'm going to create a data frame, and I'm going to just have like 4 columns of values, okay? So I'm just going to do random normal, and then my columns are going to be A, B, C, and D, and I'm going to just kind of take this, all right? So here on my index are these dates: January 1, 2000, September 26, 2002, 1,000 rows. A column A, a column B, a column C, column D. These are all kind of cumulative sums, and so they're just going to bounce around up and down. And here I'm going to just call df.plot. Just take this data frame, column A, B, C, D, these values. It's automatically going to kind of print kind of the lines all joined up together, and it also automatically creates a legend. Now this is hard to read, but let me see if I could just let's just look at the first, say, 100 rows, okay? Did that not work? Can't slice the data frame? What am I doing wrong? Oh, .iloc. Okay, that's what I want. Basic stuff. All right. .iloc.plot. All right, so here, this is just kind of like your first 100 values, okay? So that's a little bit easier to read, right? df.iloc, 0 through 100, so the first 100 values, so you're going from January to this, and so on and so forth, and it automatically creates a legend, and you know, whatever you want, right? If I do 0 through 365, then we'll get it through January through December. Let me see. If I do 366, will it give me to? No, it doesn't quite. All right. Well, anyway, this is what you see there. Okay. So this would be okay. You can say I just want, like, if you just pick one of these rows here. So here's the like the fifth row. All right, I've got just kind of a single series A, B, C, D, and if you do say plot kind equals bar, you get a bar plot, okay? And because B is negative, it actually ends up showing up negative here. But can I specify 0, 1? All right, here's here's another kind of data frame. I'm just making up some things. We're gonna pretend I've got numbers here and states. I got California, New York, Texas, Ohio, and then just arbitrary things. Tech, agriculture, manufacturing, service, other. All right, random numbers in here. Don't draw any meaning from this. So this is a data frame. Things you can call df2.plot, and you say I want a bar plot based on this data frame. Okay, and this is what it does. Is it says, all right, for tech, so it goes down the rows, and it says tech, you got a 1 for California, 7 for New York, 8 for Texas, so 1 for Ohio, and that's what you have here: 1, 7, 8, 1. Okay. So across the x-axis, it puts the index, the rows: tech, agriculture, manufacturing, service. Now, what if you wanted? What if you transpose it? df.2 transpose dot plot dot bar. Okay. Now we've got the transpose. California will be the row, and then we're going to have a color for tech, agriculture, manufacturing, service, and other. And so we have the tech here, and so on and so forth. So same information, just plotted a little bit differently, right? So that's what you have there. You can also, if you don't like here, the legend is kind of overlapping this, and if you don't like that, you can change, you can specify some options as far as this goes. All right, and this is actually where this is where something like ChatGPT comes in pretty handy. And I hesitate to show you how to use ChatGPT, but I figure you guys are using this anyway for some help. So you just say like, hey, I always say like, hi. Okay, I need help with matplotlib. Okay. All right, here is some data to make code. Or to make, all right, here's some code to make, all right, here's some data, all right. And you paste your thing there, okay? Got it. You have a data frame with this, all right, and then it says, oh, here are a few options. What do you want to do? Okay, and then you say, I want to make, all right. You say, I want the legend to go on the outside, okay? All right. Fix the following code. Why is this not working? Oh no. Did I mess something up? ChatGPT is not responding, of course. Okay, all right. There we go. All right, and then I'll say, can you fix it so the legend is on the outside? To move the legend on the outside, all right, let's see what it says. All right, so here it says do this, okay? And then you can try it out. Why am I having trouble here? Okay. All right, and so there it goes. And move the legend to the outside, and it said moving the legend to the outside. Okay, bbox to anchor, this and that, and it did that. Okay, but yeah, here I have this bbox anchor location lower left, and it creates the it puts the things there. Okay, and so we'll say thank you. All right, I know. All right, okay. So we, so you can do that, you know, stacked bar plot, you can do that. So this is, you know, anytime you kind of need to look for things, you know, it's hard to remember all of the syntax for all of these things. So that's where I think like, you know, tools like ChatGPT can be useful. You know, obviously searching on Google and saying like, okay, how do I do this and do that? You'll often find examples, which are really handy and helpful. So here's how you make a stacked bar plot and things like that. Obviously, knowing what it's capable of is handy in the first place, and then obviously if you do things often enough, you'll just remember some of these commands yourself. But the formal syntax for all of these things, I don't remember any of this stuff. Okay, so I'm often looking online, asking for a little assistance and reference there. Okay, let's go ahead and wrap things up here. I'll go ahead and give you your third view quiz answer, which is the letter D. D as in dog. D as in dog. Okay, have a great weekend. Happy November, and we'll see you next week.